In this video, we'll be using what we have learned about exponential functions and logs and natural logs to be able to solve real-world connections. You're going to invest $500 into a savings account that has a 2.5% interest rate compounded semi-annually. Automatically, that gives you the hint of which type of formula from the exponential function formula that you will need to use. So they want to know how long it'll take to triple your money. Well, if you invest $500, the triple amount of $500 is going to be $1,500. Why? Because 500 times 3, tripling your money, is $1,500. So therefore, you're going to be setting this equal to $1,500. That is your final amount that you're wanting. You're investing the $500, and you know that the interest rate is 0.025. Don't forget, always make sure it's a decimal. Compounded semi-annual means twice, and then you're raising it to the number of times it's compounded times the amount of years it takes. They want to know how long it takes. You know it's going to be 2 times some number of years. You just don't know how many years, so that is where your exponent is. So what we're going to do in order to be able to solve this is, before we can mess with this exponent, that means we can't really mess with anything else first. So what we're going to need to do is first go ahead and get rid of the 500. If we divide both sides by 500, then we'll go ahead and get 3, which is actually where the tripling your money comes from. That's why it actually is 3. If you were to double your money, that number would end up being 2. And then on the inside, you would have 1 plus 0.025 divided by 2 raised to the 2t. Now, you can go ahead and also put this together, which will give you 1.0125 and then raised to the 2t. Now that you have an exponential equation, we can actually use the inverse in order to solve it. So I can rewrite this as a log. So the log, the base, is 1.0125 raised to the 2t equals 3. So in the calculator, if I put this on the left-hand side in the calculator, I will get 88.437. And then to solve for t, I got to divide both sides by 2, and I will get 44.219. And that is the number of years it will take to triple your money. So roughly a little over 44 years. You are going to invest into an account paying an interest rate compounded continuously. So automatically you can go ahead and write the function that you are going to use, compounded continuously. You want to know how much you need to invest. So that means we don't know P. We don't know how much we're investing. But we do know that the final amount needs to be $11,300. And the interest rate is 0.043. And the number of years it's going to take is 14. So in your calculator, you can go ahead and type in e to the 0.043 times 14. Just make sure that you put parentheses around the fact that you're multiplying these two things together. Okay, so I'm just going to put a dot that you're multiplying those two things together. And whenever you do, you will get 1.825767. So to solve for P, you're going to divide both sides by this 1.8. $6,189.18 is how much you will need to invest in order for your money to become $11,300 14 years later. Element X is a radioactive isotope such that every 13 years the mass decreases by half. In a previous video, we actually discussed the formula. They gave us the formula for finding a half-life. It was P of T equals P of O of 1/2, because you're taking half, of the T divided by D. So what that means is The initial amount is 454, and you're taking half of that, meaning half of the half-life would be 227. And then you take half of that, and so that's why you're multiplying this by, that's why the base is 1/2. Now, so I'm just going to use 0.5 to make it easier once I put it into the calculator. Now, the number of years that we want to know that is remaining is 30, and D represents the half-life time. So the half-life is 13 years. Every 13 years, it goes by half. So 13 will go down for D. So T is T is time that has lapsed. D is basically the half-life. That's not half year. The half-life time. So in this case, every 13 years, half of it remains. And then this is your initial, and again, this is your final. So to find the final amount, you would just type all this into the calculator, and you will get 91.7 grams would be left, which does make sense. If it takes half every 13 years, that's going to happen twice before you get to 30. 13 years, so that's 26 years. So after 26 years, it is going to reduce by half twice. So you'll get from 454 to 227, and then 227 to like about 13.5. And then a little more than 113 is going to get you to about 91 after that. So this actually does make sense. This next radioactive decay has a half-life of 13 minutes. So again, we're going to use the P of T, which is going to equal the initial amount of the element times 1/2 or 0.5, because you're taking half every time. And it's going to be T over D. So we know that the initial amount was 970 grams. And we know the half-life is 13 minutes. 13 goes on bottom. Remember, the one on bottom is the half-life time. We want to know how long, so we want to know how much time has lapsed before it finally decays to 98 grams. So 98 grams is your final amount. They want to know how long it took to get there. So the first thing you're going to do is divide both sides by 970. When you do that, you'll get 0.10103, and that equals 0.5 raised to T divided by 13. Now that you have a variable that's in the exponent, you're going to have to use a log. So I rewrite this as log base 5 of 0.10103 is going to equal T divided by 13. If you put this into the calculator, you will get 3.307. And then to solve for T, you multiply both sides by 13, and you will get 42.99 years. So roughly about 43 years is how long it will take in order this radioactive element to decay from 970 grams down to 98 grams. A town has a population of 8,000 and grows at 4% every year. So this is actually just a very simple exponential growth, which is the formula P1 plus R raised to the T. There's no compounded anything. You're not doubling the population. It's just growing at a certain percent. So it's just a basic growth equation. To the nearest tenth, how long, so we're looking for T, will the population reach 12,000? Well, we know the initial population is 8,000. And we know that the percent is 4%, so it's 0.04. Don't forget, make sure you always put it as a decimal. And you want to know, when is it going to reach 12,500? So the first thing you're going to do is go ahead and divide both sides by 8,000. And you will get 1.5625. And then you can go ahead and add this together to get 1.04. Now you have a variable that's in the exponent. Anytime you have a variable that's in the exponent, you're going to have to take the log. So you have the log base 1.04 of the 1.5625. And that now equals your exponent. So now you can plug this into the calculator and you should get 11.379 years. So the population will finally get to about 12,500 a little after 11 years. A new car depreciates at a rate of 18%. Okay, so a depreciation value is just going to be the basic decay exponential function because it depreciates its minus. How many years will it take the car's value to become half of what it was brand new? So let's say you bought it brand new for $20,000. So they want to know, when is the car going to be half of that? So you would want to know, when is the car half of that? Or if it's $30,000, you want to know when it's going to be worth only half of that. If it was $45,000, then you want to know, again, when is it going to be half of that? And the reason I say that is because technically you do not have values for A or P. But if you were to put values in, you want to know, if you buy it at $20,000, when is it going to reach $10,000? When you divide by 20,000, you will get 1/2. If you put 30,000 in here and set it equal to 15,000, when you divide by this number to get it on the other side, you're still going to get a half. If you put 40,000 here and you want to know when it's equal to 20,000, if you divide by 40, you're still going to get 1/2. So it actually does not matter. When you want to know when is the car's value equal to half, you actually can put 1/2 on the left-hand side. Now the depreciation is 0.18, and you want to know after how many years. So you have 1/2, or you could even say, just to make it easier for the calculator, is to put 0.5, and 1 minus 18% is going to be 0.82 to the t. This, now you have a variable that's in the exponent, you will create a log equation. So log base 82 equals, of 0.5 is going to be equal to t. And if you put that into the calculator, you will get 3.49 years. So about 3.5 years after you bought a brand new car, it will only be worth half of what you paid for it.